Hello, good day viewers. In this tutorial, we are going to learn how to find the cofactor of a matrix. But we are going to center the discussion based on 2x2 matrix and 3x3 matrix. So if you are new here, consider subscribing. Press the bell icon so that you will be notified whenever I upload a new content. And don't forget to share to your learning colleagues. Now let's start with 2x2 matrix. But before we start, I want to let you know about two things. Number one, you can only find the cofactor of a square matrix. Number two, you should know that every single element in that matrix has its own cofactor. So let's begin. Suppose we have a matrix A that has these entries. We have 2, -3, 1, and 4. Remember I told you each element in this matrix has its own cofactor. So we are going to find the cofactor of each individual element here. So let's start. Let us find an individual cofactor in these elements. We have the cofactors. We have first row, first column element is donated by A11. We have A12 for this one, that is the first row, second column element. We have A21, second row, first column, which is this one. And lastly, we have A22, that is the second row, second column element. Okay, we're going to find their corresponding cofactors, then we replace them back. I told you we are going to take -1 raised to the power of the sum of the column and the row of that element. You can see this first row, first column element, we have 1 and 1. So you add 1 and 1 together, you obtain 2. Then you multiply by the minor. How do we obtain the minor? We are going to delete the row and the column of that element. You can see this is the element we have. You delete this row, you delete this column, we are left with only 4. Then we multiply by 4. If we simplify, we are going to obtain the cofactor of that element, which is A11. Moving on here, we have -1 raised to the power of 1 plus 2, which is 3, multiplied by the minor, and that minor is going to be obtained by deleting the row and column of that element. A12 is this element. We close this column, we close this row, and we have -3 multiplied by -3. Moving on, we have A21, that is the second row, first column element, which is this. But we have to multiply by -1 raised to the power of 2 plus 1, which is the same thing as 3. Then multiply by, you delete this, you delete that one, you are left with only 1 here. Moving on to the last one, we have second row, second column element, which is this one. We take -1, raise it to the power of 2 plus 2 is 4. Then multiply by the minor. And how do we obtain the minor as well? You close this column, you close this row, you are left with 2. So now let us simplify and obtain our corresponding cofactors. For this one, you know, when the power is even, it is going to transform the negative sign to positive. So because of this is even, this -1 becomes +1. +1 times 4 is 4. This is an odd power, so the negative sign will remain negative. -1 times -3 is +3. This is also an odd power, so this will remain negative. -1 times +1 is -1. And lastly, this is an even power. This becomes +1 times 2 is still +2. So now we are going to substitute them back into their corresponding positions. All right, the cofactors of this matrix A will now be equal to the cofactor of A11 is 4. You know, A11 is the first row, first column element, which is now 4. First row, second column, this is the same first row, then second column is 3. Second row, first column is -1. Second row, second column is +2. So now you can see the matrix is entirely different, just that they must have the same dimension. This is 2 by 2. Even the cofactor will remain 2 by 2, but elements are not exactly the same. So this is how to find the cofactor of 2 by 2 matrix. Now let us look on to how to find the cofactor of 3 by 3 matrix. So first we have a matrix A. Again, let me use A. 3 by 3. We have 1, -2, 0. We have maybe 2, 3, 4. Maybe -2, 2, and 1. You can see this is 3 by 3 matrix. It has 3 rows and 3 columns. Again, if you observe something, this is A11. 1 plus 1 is even. This is A12. 1 plus 2 is odd. A13. 1 plus 3 is even. So once that element is under an even position, it is going to be multiplied by +1. Once that element is under an odd position, it is going to be multiplied by -1. So we can develop something in this form. So this matrix, to find the cofactor of these entries, the first element here will be positive, will be multiplied by positive, negative, positive, negative, positive, negative, positive, negative, positive. So instead of multiplying each minor by -1 to the power of the sum of the row and column of that entry, we can admit this. Okay, now the cofactors. We are going to find the cofactors of each of these elements. We have A11, we have A12, we have A13. This is A13. We have A21, we have A22, we have A23. Then lastly we have A31, A32, and A33. Okay, for this one, you can see this one is positive, so we have positive. We close this column and this row, but we are left with 4 elements. Instead of 1, you know, in 2 by 2, we are left with 1. But since we are left with 4 elements, we are going to find the determinant of these 4 elements. So we are going to find the determinant of these 4 elements for A11, which is going to be 3 multiplied by 1 is 3, then minus 4 multiplied by 2, which is 8, and we are going to obtain -5. So this becomes -5. A12, this is A12. Let me take this down. For A12, we are going to delete this and this. We are left with 1, 2, 3, 4. As well, we are going to find their determinants. -2 multiplied by 1 is still -2. Then we subtract. We have 0 multiplied by 2 is still 0, and this is -2. All right, remember, this is A12. A12 is already negative, but multiplied by -2. Okay, moving on to A13. This is A13 is positive. A13, we close this, we close that. This is the only 4 elements we have. This time this is -8, this time this is 0. -8 minus 0 is still -8. So this is -8. A21. A21, that is the second row, first column. You see it is negative. So we have negative multiplied by the minor. We close this, we close that. We have this, 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 and this. So to find the determinant of this, we take 2 multiplied by 1 is 2 minus 4 multiplied by negative 2 is negative 8. Negative 8, negative is positive, so we have 10. So this is 10. A22. This is A22. We close this column, we close this row, we have this, 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 and this. Find their determinant. We have 1 times 1 is 1, minus 0 times negative 2 is 0, so we have 1 here. But what do we have here? A22. This is A22 is positive. Multiply by 1. Okay, moving on, we have A23. This is A23. Under this 2. We close the whole of this and this. This is what we have left. But this is negative. You can see it corresponds to negative. So we have negative sign before finding determinant. Determinant is going to be 1 times 4 is 4. 0 times 2 is 0. So 4 minus 0 is still 4. So we have minus 4. A31 is positive. You can see it here. So we have positive. A31, you close this, you close that. This is what we have left. You find their determinant. 2 times 2 is 4. Minus 3 times negative 2 is negative 6. We have negative 6. Negative, negative, positive. This is equal to 10. So what we have here is 10. Moving on, we have A32. A32 is negative. So we have negative sign. We multiply by the minor. The minor for that A32. This is A32. You close this. You close that. You have this, 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 and this left. Determinant 1 times 2 is 2 minus. Negative 2 multiplied by negative 2 is positive 4. So we have positive 4, and this is equal to negative 2. So we have negative 2 here. The last but not the least is going to be positive. A33, this is A33. You can see it is positive there. You close this, you close that, you have this, 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 this left. You find the determinant. 1 times 3 is 3 minus negative 2 times positive 2 is negative 4. Negative, negative is positive. This is equal to 7. And we have 7 here. Okay, now we're going to simplify this and plug them back in here. So I can take this down. Therefore, the cofactor of this matrix A will be equal to, we start with A11. Positive, negative is negative, so we have negative 5 here. A12, negative, negative is positive, so we have 2 here. A13, positive, negative is negative, so we have negative 8. A21, we have negative 10. Negative 10. A22, we have positive 1 because this is positive. Moving on to A23, we have negative 4 here. A31, we have positive 10. This is negative, positive. We have 2. And lastly, we have 7. So this is exactly the cofactor of this matrix A. And this is exactly how to find the cofactor in traditional way. So this is all I have for you today. Thank you for watching. Do have a nice day.